Hello, and today we are going to learn about the multiplication property of equality. You see it right in front of you. If A equals B, then A times C is equal to B times C. Basically, if you have an equation with two terms, you can multiply both terms by the same constant and still have an equation. Alrighty? We're going to use that to solve equations today. To do that, though, let's identify what the multiplicative inverse means. So if we have two numbers multiplied together and those numbers equal 1, then A and B are multiplicative inverses of each other. So what are two numbers that multiply to give you 1? How about 2 times, I don't know, what times 2 would give you 1? 1/2? Yep. Okay, let's take something like negative, 6. What times negative 6 would get you 1? Well, it'd have to be negative, and it would have to be a sixth. So negative 1/6 times negative 6 is equal to 1. So these are multiplicative inverses of each other. All right, we're going to use that combined with the multiplication property of equality to solve equations. All right, let's start off with two simple ones, and then we're going to get to the complex stuff. 3 times x is equal to 15. Remember that 3x is 3 times x is equal to 15. Okay, so we want this to be just x, meaning we want this 3 to become a 1, because we want the coefficient of x to be 1. 1 times x is equal to x. So what can we multiply this 3 by in order to make this become a 1? Well, what's 3's multiplicative inverse? That would be 1/3. 1/3 times 3 would give you 1, and then 1 times x is just x. Awesome. But we have to use the multiplication property of equality to balance out this equation. Whatever we multiplied the whole left side of the equation by, we have to multiply the entire right side of the equation by the same thing. So what's 15 times 1/3, or 15 divided by 3? That would be 5. X is equal to 5. Okay? All right, let's take a look at one more simpler one, and then we're going to move on to the complex stuff. 1/2 times x is equal to negative 6. All right, and again, remember that this is 1/2 times x. So what can we multiply a half by to make it 1? Or what is 1/2's multiplicative inverse? That would be 2. 2 times a half is 1. And then 1 times x is x. Boom, we've isolated the x. But we also need to balance off the right side of this equation. We multiplied the left side of the equation by 2. We have to do the same thing to the right side. And negative 6 times 2 is negative 12. There's our solution. Alrighty. Now, instead of doing another one which is just the multiplication property of equality, what we're now going to do is combine the addition property of equality and the multiplication property of equality. We're going to do this so that we can solve two-step equations. The first examples that I'm going to show you are the exact same equation solved two different ways. So here's the first way I'm going to do this, and this is the way that you probably would do this on your own. 4x plus 12 is equal to negative 8. So I need to do two things. I need to make this 12 become a 0, so it's x plus 0, and I need to make this 4 become a 1, so that it's 1 times x. All right, let's take care of the 12 first. That's probably the way that you would do it before. So we're going to need to use the addition property of equality and additive inverses. What can I add to 12 to get it to become a 0? That would be a negative 12. And again, using the addition property of equality, I would have to add that negative 12 to the right side as well. So all I really did that's different from the top to right now is I added a negative 12 to both sides. 12 plus negative 12 is 0, so I have 4x plus 0, which is just 4x. Negative 8 plus negative 12 is negative 20. Now I need to make this 4 become a 1 because it's a coefficient, and I need my coefficient of x to be 1. So what can I multiply 4 by to make it 1? What is its multiplicative inverse? And that would be 1/4. 1/4 times 4 times x. And again, I would need to do the same. I need to multiply the right side of the equation by the same thing as well. 1/4 times 4 is 1, and 1 times x is x. Negative 20 times a fourth, or negative 20 divided by 4 would be negative 5. So there is my solution. That's probably the way that you would do it. I want to show you that though we use the addition property first and then the multiplication property of equality, you can do it in reverse order. It's totally algebraically fine to do the multiplication property one first. In fact, it helps when clearing out fractions, which we'll do in another video. Alright, say I wanted to take care of this coefficient first. I would need to multiply the left side of the equation by this multiplicative inverse, which would be 1/4. Okay? To do that, to clarify, need to multiply the entire left side of the equation by that 1/4. And then we need to multiply this side by 1/4 as well. So I'd have to really be distributing this 1/4. So 1/4 times 4 is 1 times x is x. 1/4 times 12, or 12 divided by 4 is 3. So distributing this 1/4 gives me x plus 3 on the left side. And then negative 8 times a fourth, or negative 8 divided by 4, is negative 2. And then all I have to do is get rid of this 3. It's added to it, so I need to think what's its additive what's its additive inverse? What can I add to 3 to make it 0? And that would be negative 3. And then using the addition property of equality, I have to add that negative 3 to the right side as well. So x plus 3 minus 3 would be x plus 0, which is just x, and negative 2 plus negative 3 is negative 5. Notice that the solution did not change, whether we did the addition property of equality first, or in this case the multiplication property of equality first, I get the same solution. So there should be a little bit less stress about how do I solve the problem the correct way. There's no correct way to do it. There's easier ways to do it. In this case, either one of these I think is perfectly acceptable in terms of the amount of easiness. Alright, so let's look at this one. See, this is an example where I would not use the multiplication property first, because I'd have to multiply this side by negative 1/2, and 19 times negative 1/2 is not a nice number. So I would use the addition property of equality first. What do I add to 19 to make it become 0? What's its additive inverse? That'd be negative 19. And then I have to do the same thing to this side, 71 plus negative 19. Okay, so we have negative 2x plus 0, which is 2x, and we have, this is positive 52 on the right side. Now, we need to multiply this negative 2 by something that would make it become 1. So what is negative 2's multiplicative inverse? Well, it has to be negative, because a negative times a negative is a positive. And it has to be 1/2, because 1/2 times 2 is 1. So negative 1/2 times negative 2 times x is equal to 52 times, we have to multiply this right side by negative 1/2 as well. So negative 1/2 times negative 2 is 1. 1 times x is x. And then 52 times negative 1/2 is negative 26. And that's your solution. If you substituted it back into the equation, negative 2 times negative 26 is 52. 52 plus 19 is 71. So you've solved for x. Okay. The next video, we're actually going to use the multiplicative inverse and the multiplication property of equality to clear out fractions. But for right now, you now have the tools to solve two-step equations. All you need is the addition property of equality with additive inverses and multiplication property of equality with multiplicative inverses. And you can solve a two-step equation in any order you want. All right? Power.